Hi. In this second presentation of the Groundwork playlist, we will look in more detail into the three sections comprised in a VHDL description file. At the end, I hope that you will be able to explain what is the meaning of each of these three sections. We will also compare different modeling styles to describe the function of the circuit in the architecture section, so I hope that you will likewise be able to explain the differences between data flow, behavioral, and structural descriptions. Accordingly, the presentation is organized in two parts. The first one addressing the three sections comprised in a VHDL description file, and the second one looking into the three modeling styles just mentioned. So let's start by the three sections. What you see here is the familiar VHDL description of the 224 decoder. On the left, we see a logic diagram that is commonly used to represent this function, and on the right, an equivalent VHDL description. Notice the names highlighted in red to identify the three sections: library, entity, and architecture. We had already briefly introduced the other two sections, but we hadn't said anything about the library. The library clause makes available a collection of packages that contain predefined data types. In this case, we are declaring the use of the standard logic 1164 package belonging to the IEEE library. It just happens that this package predefines the data type standard logic, meaning that we will be able to use it without defining it explicitly. Standard logic is actually a data type comprising 9 possible values, including the commonly used 0 and 1, and in addition 7 more values that include high impedance, unknown, etc. You may search online to check the full description of this data type. Depending on what data types and operations you use, you may need additional package declarations. For example, if you need to perform arithmetic addition, you may want to use the unsigned data type, and in that case you will need to declare the numeric standard package. The entity, as we have already seen, describes the inputs and outputs of our circuit. Recall that it does not describe what the circuit does, but just its interface. The architecture, which is the main section in a VHDL design file, describes the function of the circuit. It explains what the circuit does, although not necessarily how it is done. In this case, however, it very much states how it is done, since we provide a sum of products description. So let's look at the different forms of describing the function of the circuit. The data flow modeling style enables us to visualize how the data flows through the circuit. In a behavioral modeling style, we see what the circuit does, but not how it does it. And finally, in a structural modeling style, we describe what the circuit does by interconnecting lower-level modules with predefined functions. The data flow description is actually the one that we have been using as an example, so there is not much more to say about it. The generic technology model generated by Vivado Synthesis for the data flow description is shown here for the sake of completeness, but you had seen it before. We will now consider two behavioral descriptions, the first of which uses the when-else construct to describe the circuit. We will revisit this statement later, but you shouldn't have any difficulty to understand what it does just by looking at this architecture section. What you won't be able to realize is how it is done. Will it be using multiplexer structures, sum of product structures, or any other possibility? Vivado will just decide, and we will focus on what we want, not how it is achieved. Here you see the generic technology model created by Vivado Synthesis for this case, comprising AND gates and logic comparators. It's interesting to notice that Vivado estimates the need for 8 FPGA cells, less than what was estimated for the dataflow description. This slide shows an alternative form of behavioral description where with select statements are used instead of when else. We will provide the formal introduction to this concurrent statement later, but you will understand what the circuit does just by reading the statements. And here's the generic technology model created by Vivado Synthesis from this description. Notice the use of read-only memory blocks, and that Vivado estimates the need for only 4 cells. To illustrate the structural description style, I have chosen to create a 3 to 8 decoder using our pre-designed 2 to 4 decoder block. The code at right is reasonably self-explanatory and basically consists of declaring a 2 to 4 decoder component and instantiating it twice, inverting one of the inputs in the second case. In this case, we see that Vivado was actually tied to the structure that was imposed in the VHDL description, so the generic technology model created is nothing more than a replica of what we have just described. Since the 1993 revision of the IEEE standard, we can declare the structural blocks using the alternative construct shown in this slide. It is just an alternative form of providing the same structural description, so the result shouldn't be different. And it isn't, as you see here. Vivado continues to be tied to the structural description provided. Finally, be aware that it is possible to provide more than one architecture section for a single entity description in the same VHDL design file. We may state which architecture to use when invoking this module at an upper level structural description, but if nothing is said to the contrary, Vivado will simply pick up the last architecture described. Well, it was only 2 topics, but a lot of information. That's it for now. Thanks for your attention.